Hello, welcome back again to SCADA123. Today we're going to talk about the PMD-1208. That's an MCC DAC board with differential channels, as you can see here, 0 through 3. We'll start with the main window of analog input. The analog selection can be either analog in which case you're just doing a number of samples with an interval delay in between. Not highly accurate, but if you just want to grab some points every second or every couple of seconds and you're not too partial on the exact timing, pretty quick, simple, and nice. Let's just do that for a quick example. Click Run A, and there you can see each of those channels, 0, 1 through 10 points. Now, if you want to get a look at what that actually looks like graphically, you can go to your output. You can click on the analog input data just to kind of re-see it again to see what the data is. Click on Matplot Graph and you'll actually see the graphic of that data right here. You've got your legend, you've got all the Matplot options, and you can do whatever you'd like there. When you're done and happy, you can just close and then continue on. Now let's go back to our main again and show you the Run Analog Scan. Now that still uses the same number of samples there, but your sample rate is going to be much higher, whatever you like. It's internally to the board, and so you're going to be dumping the data to the memory, so it's much faster, much more accurate. You can go from channel low, which is defaulted to 0, and then you can select channel all the way up to 3. Now when you're ready for that, just click Run Analog Input Scan, and you'll basically see the data as well. You can do the same thing. Now let's go quickly, we'll go to the digital analog output, but you can just set these whatever you want, 0 through 5 for this board. Click Set 0, Set 1. You'll see the actual board values and then the volt representations there. Now, pretty quick and simple, we'll go to our digital. Now, on our digital input outputs, this actually has ports A and B, but we'll just use port A here. Now, to see what looks at, say, bit 0 on that port, let's run the digital in. So bit 0 is true. So, if instead you want to do outputs, now you're going to have to change the wiring to make it work, but you can just click Run, and it's going to give you the port output. This is a byte that it sends of all of these, not each one individually. So let's say we want to do all of them. Now you're going to have the entire byte filled up. Gives you a value 255, 1, 2, 4, so on, all your digital values. Now, in addition to what we've got for all of our frames here, you also have info, which will give you the information about the board. You'll get blink, which will blink the LED. You have help, Python, and about, which gives you what your current Python is running, as well as about this application. Now, in addition, you also have file, open, and save. If you click save before you run the analog inputs, it will save that to a file. If you already have a file existing, these are CSV files, you can click open and grab that and say look at it in Matplot. Now the exit, in addition to closing the application, also closes all the digital and digital analog outputs, so you have a safe shutdown. You don't have to worry about having it left on, possibility of shorting an issue if you start changing things and don't realize it was left on. In addition, since you're running the executable here, you're going to see your data in the Windows command prompt screen. So you want to open it up there, and then you'll see your print results in that terminal. Otherwise, what you'll see is what you get in the scroll text boxes. Hope this helps. Thanks a lot. Bye-bye.